Today we get to talk about section 10.2, which is triangles, and we are going to solve problems involving angle relationships in triangles. We're going to solve problems involving similar triangles and those dealing with the Pythagorean theorem. So, first off, you have the measure of an angle A. They're asking us to find the measure of angle A for triangle ABC. So, hopefully you remember that all the angles of a triangle add up to 180 degrees. We're looking for angle A, so we're going to carry that one down. The measure of angle B from our diagram is 120. The measure of angle C from our diagram is 17, and all of those add up to 180. So again, we carry down the measure of angle A, we combine these two and get 137, and we carry down 180. So if measure of angle A plus 137 equals 180, then we know that 180 minus 137 is going to give us the measure of angle A, which is 43 degrees. So try one on your own if you want to pause, or you can continue to watch as I do the next one. All right, we're using the same diagram, but this time B is 116 and C is 15. So along those same lines, we're looking for the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180. So we combine 116 and 115, and we say the measure of angle A plus 131 equals 180. And then we're going to subtract 180 and 131 and find out that the measure of angle A equals 49 degrees. All right, next example. We're going along the same concept, okay? We're trying to find all these angles measures 1 through 5. So, hopefully you can see, we'll start with this triangle because I know what the measure of angle 1 is. I hope you can see that. Because of my symbol here telling me it's a right angle, I know that 1 plus 2 plus 43 are in a triangle, so they're all going to add up to 180 degrees. The measure of angle 1 is 90. The measure of angle 2, we don't know. And of course we have our 43 and our 180. Okay, so we bring down measure of angle 2. 90 plus 43 is 133. And we carry down our 180. So again, 180 minus 133 is going to give us the measure of angle 2. So 2 is 47 degrees. Okay, now going back, we have another triangle, same picture. Okay, we're still trying to find. So this one we just figured out that angle 2 was 47. So I can go ahead and write that in for you. That's 47 degrees. 3 is 47 degrees also because it's a vertical angle. Measure of angle 4 and then 60 all add up to 180. Again, 40, well, if we combine these two, 60 and 47 are going to give us 107, and we're going to subtract that from 180 to find the measure of angle 4. So 3 we know is, I'm going to draw a little arrow, that's 47 degrees also, and we just figured out that 4 was 73 degrees. So we have left to find the measure of angle 5, and hopefully you can remember that these two are supplementary, so that means that they add up to 180 degrees. Measure of angle 4 is 73. If we don't know the measure of angle 5, they add up to 180, so the measure of angle 5 is going to be 180 minus 73, which is 107 degrees. So that's the last one that we had to figure out. Okay, let's review how we classify our triangles. First off, we classify them by angles. If all the angles are acute, then we have an acute triangle. If one angle measures 90 degrees, we have a right triangle. And if one angle is obtuse, we have an obtuse triangle. We can classify them by their sides. If we have two sides that have equal lengths, we would know that because we have two tick marks or a tick mark on the two sides that are equal, that is an isosceles triangle. If all sides have equal lengths, you would have a tick mark on all three sides. Then we have an equilateral triangle. And if no two sides are equal in length, then we have a scalene triangle. Okay, we're also going to talk about similar triangles. So remember that similar shapes, similar figures, have the same shape, but not necessarily the same size. In similar triangles, the angles are always equal, but the sides may or may not be the same length. So corresponding angles are angles that have the same measures in the two triangles, and corresponding sides are the sides opposite the corresponding angles. So here's a picture of similar triangles. They're telling us that ABC, triangles ABC and DEF are similar. Remember that this is your symbol for similar. And if they are, then these are the corresponding angles and these are the corresponding sides. And what you want to remember when you work problems that are dealing with similar figures, okay, is we have that the measure of angle A equals the measure of angle D, the measure of angle C equals the measure of angle F, and the measure of angle B equals the measure of angle E. And this side, our sides are what we say proportional, so we have an extended proportion, which means that we have more than two parts to it. And you can choose any two parts that you want, but you want to make sure that the same triangle is on the top or the bottom. So I'm going to put AC, AB, and CB on top. AC corresponds to DF, AB corresponds to DE, and CB corresponds to FE. So let's look at what kind of problems that you'll have to do with similar triangles. So here's an example of two triangles. They are similar, and hopefully you can see that they're similar. And we'll talk about that. Okay, so first off, when we do our solution, they're similar because their corresponding sides are proportional, and we have the angles. We know that their angles are equal because we're going to know that this angle has to be equal to that angle because those are vertical angles. Okay, so I can replace that. Let's remove that. Okay, so we have our vertical angles that are equal. These are the ones that are given to us that we already know are equal. So we're going to go find the angle that is the opposite angle with one tick mark. So the side that is opposite one tick mark is a 5 in the small triangle. I have to get my arrow, excuse me. Is a 5 in the small triangle. Opposite the big arrow, excuse me, one tick mark in the big triangle is the 8. Opposite two tick marks in the small triangle is a 7. And opposite two triangles in the large is an 8. Excuse me, is an X. So what we have done in this case is our proportion is the top has the small triangle and the bottom has the large triangle. So you got to make sure you keep those parts organized or you will get incorrect answers. Okay, so let's go solve that proportion. 5 over 8 equals 7 over x. Remember that we cross multiply. And one of the things that I always tell my people when they cross multiply, we used to form a pretzel. We start at the bottom so that we keep it on the same side as the numerator. So our next line is going to read 5x is equal to 8 times 7, or 5x equals 56. Then we divide both sides by 5, and we find out that x equals 11.2, or 11.2 inches. So here is a different figure, and we're going to go, it says explain why the triangles are similar. They're similar again because of our angle-angle similarity that we've learned. Okay, we have these two angles that are both 90 degrees, and these two are the vertical angles. Okay, so you want to keep in mind which triangle are you going to put on top? Small over big. So go to your small triangle. Pick a side, it doesn't matter which one, but opposite the one tick mark is 8 centimeters. What's opposite one tick mark here is 12. And in the small triangle we have 10. And in the big triangle, opposite that other angle is going to be your x. Okay? So we can cross multiply. 8x equals 120. Divide both sides by 8, and you will get that x equals 15. So the answer we'll put in our blank would be 15 centimeters because we have a label and we need to make sure we put those labels on our answers. Okay, another thing I know everybody's familiar with is the Pythagorean theorem. Now here are the words that tell you about that. The sum of the squares of the lengths of the legs. The sum of the squares of the lengths of the legs. Do you remember which one's the legs? We have a right triangle here. The legs are, of course, the ones that form the perpendicular sides. And the other side, I hope you remember, is the hypotenuse. Hypotenuse is always the longest side and opposite the right angle. Okay? So if you put a square on the legs and you add those two areas up, you will always get that number. Always. So in this small one, we had 9 square units. And over here, we had 16 square units. And that means that when we add 9 and 16 together, we get 25 square units. But that's a visual to kind of help you remember. A shortened version of that from you've learned before is that a squared plus b squared equals c squared. So one last example. In using your Pythagorean theorem, okay, the most important thing is going to be setting it up. You're looking for the length of the hypotenuse, okay? So if we're looking for the hypotenuse C, then we're going to let A equal 9 and B equal 12. Does it matter if A is 12 and B is 9? Absolutely not. But what matters is that it's not the hypotenuse. So C squared equals A squared plus B squared. Then I'm going to fill in A is 9, B is 12. I square both of those. 9 squared is 81. 12 squared is 144. Combine those. C squared equals 225. And then we take the square root of both sides. The square root of 225 is 15. So our answer is that C equals 15. That sums up our triangles. Write down any questions that you have and come to class ready to work.